Hi team, welcome to a quick Delta Math walkthrough for all of the different problem types. So if you're working after the meeting and I'm not available to you, you can refer to this video and see some ways to approach these problems. So this problem asks us to find the sum of the first 10 terms of the following series. Notice that it didn't tell me if it's arithmetic or geometric, so I have to look at it. 1 is the first term, 5 over 6 is the second term. So it got smaller by 1/6. And then if it was arithmetic, the next one would be 4/6, 3/6, 2/6, etc. But it's not. It's 25 over 36. Aha! If I multiply 1 by 5 over 6, I get 5 over 6. If I multiply 5 over 6 by 5 over 6, I get 25 over 36. Okay, so it's a geometric series. It's working by multiplication, in other words. That's what we're looking for. So let's analyze it. And then we can find the sum of the first 10 terms. I expect that this is going to be something like, I don't know, around 4. I think it's going to be like maybe add up to maybe between 3 and 4, maybe less, maybe closer to 3. So here we go. We have 1, 5 over 6, 25 over 6, 36, sorry. And then we know that our A is equal to 1. That's this number. And then our R is equal to 5 over 6. I hear someone is arriving in the chat. Let's go see who it is. All right, so we're back. And while I was gone, I realized that there's an infinite series of me here. It's kind of topical. And I can give myself cheers and drink my coffee. Cheers. Okay, so let's carry on, everyone. Here we go. We were looking at this Delta Math series, and we found A is 1 and R is 5 over 6. So let's sum this up, shall we? Move me. There. Okay. So we know our formula for the sum of a geometric series of n terms is equal to the first term multiplied by 1 minus r to the n all over 1 minus r. Okay, now A is 1, so that's fine. We're just going to write down 1 minus 5 over 6. That's our r. And what's our n? Well, we've been asked to find the first 10. Okay, so 5 over 6 to the 10. N brackets, all divided by 1 minus 5 over 6. Okay, S of 10 is going to equal to, this is going to be 1 over 6, because 1 is 6/6, then 5/6 is 1 less than that. So that's 1 over 6 on the bottom. And then 1 minus 5 over 6, so that's 5 to the 10 over 6 to the 10. At this point, we're going to do a decimal approximation. They want it to the nearest integer, so it's to the nearest 1. So let's go ahead and do this in the calculator. My face keeps on finding a way to be in the wrong spot. 5, let's clear everything. 5 divided by 6 is 5 over 6. That's this number. I am going to take this number and raise it to the power 10. It's going to be a very small number. Equals. Okay. Well, it's not very, very small. I thought it was going to be a little smaller than that. I'm a little surprised. Anyway, here we are. 0.1. Okay, sure, fine, Mr. Jennings, just trust your calculator. I don't see why that could be wrong. And then I want 1 minus this number. So let's flip its sign and add 1 to it. Okay, and so that's this number on top. And I am, just to remind you, this was 5 over 6 to the 10, was that like 0.16 something something. When I 1 minus that, I get this number here. And now I'm going to divide that by 1/6. Okay, I'm going to write the decimal approximation in here right now. 0.8384, 8385, 0.8385. Notice that the reason why I'm switching from fractions to decimals here is because 5 to the 10 over 6 to the 10 is such a crazy, wild number that I don't really want to work with it. Like, at that point, I'm going to be like, okay, we're just decimal approximating here. And now I multiply this number by 6, and that will be the answer. Times 6. Why did you multiply by 6, Mr. Jennings, and not divide by 1 over 6? Well, dividing by 1 over 6 is the same as multiplying by 6. So there we go. The answer is 5.03. So the answer here for the Delta Math is 5, because that's the closest integer. There, put that in, enter, enter. Hooray! Okay, there we go. And then let's see, where do they, common ratio, yeah, you see they found the common ratio. The first term, they put that in there. They just use decimals as well. And they switch to decimals at the same time as me. Delta Math and I often agree. Let's take a look at another example. This one here, 13 goes to 22, goes to 31. This is arithmetic. Okay, I know it's arithmetic because 13 is such an ugly number that to take it to 22, yeah, you could do that with a geometric series, but then this would be a fraction right away and it would be gross. Okay, you would have to be multiplying 13 by 22 over 13. So then you would have 22 squared over 13 here. It'd be gross. So, and there's no common factors. So that would be exactly what you would have. All right, so this is an arithmetic series, and so we want to add it up together as though it's an arithmetic series. And when I'm doing that, I'm going to have 13 is my first term, and then 22 minus 13 is 9. 31 minus 22 is 9. So 9 is the common difference. All right. Now the sum of the first 33 terms of an arithmetic series is equal to, well, let's do the formula first. Okay. All right, so the formula here, let's recall it. S of n is equal to n over 2 multiplied by 2 times a plus n minus 1 times d. Okay? And I'm like, well, let's just make sure, Mr. Jennings, that's the right formula. Because what if it's not? And then you make a mistake. Okay, and I just got it in the document there for you, and it's in your textbook, and it's in the videos, so there's lots of places you can find that. All right, there we go. So let's keep going. Back to Delta Math. And go back here. Okay, so now we substitute in 33 over 2. I'm just going to leave that because it's going to cancel out in here anyway. 2 times a was 13, so this is 2 times 13 plus n minus 1. N is 33, so this will be 33 minus 1, all multiplied by d. d is 9. Okay, and I don't have to divide by anything because that is what it is. Okay, this is equal to 33 multiplied by 2 times 3 is 26. There are fancy ways to factor this right now, but I don't want to do that. 26 is 2 times 3 plus 32 times 9. 32 times 10 would be 320. So I just need to subtract a 32 from 320, and then I will get, is that 288? I think it's 288. Let's see. 32 times 9 equals 288. There we go. Okay, so this is 26 plus 288. All over 2. Okay, this 2's going to come down there. Sure, fine. And then 26 plus 288. 314. And I have to multiply this by 33. Here we go. Times 33 equals, and divide by 2 equals 5,181. Okay, let's check this in Desmos. 5,181. All right, so you want to be properly excited when you do these correctly. Let's take a look at the next problem type. Geometric series level 1. Okay, find the sum of the first 10 terms of the following sequence, rounding to the nearest hundredth if necessary. Okay, and this one is a little trickier. But they give us the formula there. It's different than the formula you gave us, Mr. Jennings. No, it's not. Not different. It's just not factored. They did not factor their formula. Okay, I'll prove it to you. S of n is equal to a1, this is the first term, minus a1 times r to the n, all over 1 minus r. But you told us, Mr. Jennings, yeah, I know. Okay, S of n equals factor a1 out. They're calling a1 the first term. We call a the first term, okay? And then we have 1 minus r to the n. All right, it's just the a is factored out, okay? It's the same. It's the same and it's the same. You can use either one, whichever one you like. If you like doing more multiplication, do that. If you like working with something simpler, do that. Let's keep going. All right, so we're told it's a geometric sequence. We're reminded of the formula, and then we want to work with this. So what's the common ratio? Okay, a is our first term, and that's 11. We know n is 10, the number of terms, because we want to sum the first 10 terms. And r, well, we divide this one by this one. So 55 negative divided by 11 equals negative 5. So this is our r. R equals -5. Let's just check. If I multiply this by -5, look, I get 275. Look, that works. Okay, 50 times 5 is 250. 5 times 5 is 25. This was negative. It's multiplied by a negative, so this is positive. So it's indeed, this is the ratio. All right, so now input into this formula or that formula. I'm going to use our formula because I'm not a maniac. Okay, so let's move that up there. Here we go. The sum of the first 10 terms of this series is going to be 11 multiplied by 1 minus -5. Put that in brackets. Substitute into brackets always when you have like negatives and stuff. Raised to the power 10. Okay. Notice that this negative comes along for the ride. So when this is negative, it's going to end up being positive when you have an even number of terms and negative when it's an odd number of terms. Yes, positive when it's an even number of terms, negative when it's an odd number of terms. This is even, so this will work out to be even. Okay, and then 1 minus -5 on the bottom. Okay, let's do it. 11 multiplied by 1 minus -5 to the 10. So that I'm going to do in my calculator for darn sure. 1, clear. 1 minus 5 negative raised to the power 10. And I have to push equals twice. No, it did it wrong. It did not do the bedness correctly. I do not like this calculator. Have I ever mentioned that I do not like the calculator that's on this computer? 1 minus bracket -5 and bracket raised to the power 10 on my calculator. It works much nicer. Equals, oops. Undo. Can I undo? No. Okay, it's this number that I want. I'll show you. I just pushed equals too many times. This is it here. This number. So I can copy that. Copy. And then over here and paste just a number. Yes, I can. Beautiful program. All right, so now let's grab that. Hey, okay, fine, we got it. Yeah, okay, here. Move this down here. That's the number that goes in the brackets. Okay, there we go. Show all over 1 minus -5. So that's all over 6. Okay, so now let's multiply this by 6. Then multiply it by, what is it? We're going to multiply by 11 and divide by 6. Okay, clear. Paste that number back in. Okay, times 11 equals big number, divide by 6 equals. Let's take that number, copy, put it into Desmos and see what Desmos says. Now, does that feel reasonable? Okay, why would this be a rather large negative number? Because these terms are alternating between big positive, bigger negative, bigger positive, bigger negative, bigger positive, bigger negative. Okay, so the very last term that you get has the huge influence on the sum of the whole series. If it's a very big negative term, it overwhelms all the stuff that came before. If it's a very big positive term, it overwhelms all the stuff that comes before and makes it go that way. So that's why you have the size of this series alternating between very big positive and negative values as you go forward. Okay, submit answer. Oh, I can't use commas. Okay, so the reason I can't put that in is because my calculator puts commas for my viewing pleasure. Hooray! Okay, so there we go. All right, a geometric series level 2. What's harder about this? Find the sum of the following series, round to the nearest hundredth if necessary. The trick here is I'm not given n. I have to find n. So let's do it. Okay, so here's how you would approach this type of problem. First, write it down. 5 plus 10 plus 20. Pretty easy to see. This is geometric. It's growing by a factor 2 every time, not a factor 5, Mr. Jennings, factor 2. Okay, dot, plus 320. Okay, at some point this is going to have a term that's 320. I want to know what term number is that. So let's find that out. First, our A is equal to 5. Our R is equal to 2 because I'm multiplying by 2 here every time. Okay, I can divide. You can divide 20 by 10 is 2. Divide 10 by 5 is 2. But I'm not going to do that. I'm just going to write down R as 2. Okay, now I can create a general term. And then I'm going to solve for this one so I can solve for what term is n. Okay, so here's my general term. T of n is equal to the first term, 5, multiplied by the ratio 2 raised to the power n minus 1. Put that in brackets too for your viewing pleasure. Now, I know t of n. I want to know what is this nth term, like what number is it? So it's 320 is equal to 5 multiplied by 2 to the n minus 1. Now do your bedmas as much as you can. Divide both sides by 5. So 320 divided by 5 is 64. 64 equals 2 to the n minus 1. 64 is a power of 2. Which one is it? 2, 4, 8, 16, 32, 64. It's 2 to the 6. So this is, I can write this as 2 to the 6. And therefore 2 to the 6 is equal to 2 to the n minus 1. So n is equal to 7. 6 equals n minus 1. I can take the bases away because this must be equal to that. And then n equals 7. Come on, that's just what it is. All right, so now I've got all that I need. So now let's write out our a again. Our a was equal to 5. That was our first term. Our r was 2. And now I know our n is equal to 7. So now I can take sum all of this as a geometric series. S of 7 is equal to a is 5. So I can just write out the formula for you here. S of n is equal to a times 1 minus r to the n over 1 minus r. Okay, so a is 5, so I'm going to put in 5 there. Multiplied by 1 minus 2 to the 7 all over 1 minus 2. Okay, s to 7 is equal to 5 times 1 minus 2 to the 7. Well, 2 to the 7 is 2 times 64 is 128. Okay, so this is 5 times 127 all over negative 1. Oh, sorry, this is negative 127. Ha, ha, ha. See, I made a mistake. 1 minus 128, not 128 minus 1. Okay, this is minus 127. So the negatives will cancel. La-di-da-di-da. So 5 times 127 is... I feel like dirty doing this on a calculator. I just want everyone to know this is like, this should be done in your head. 635. I'm just not doing that because, hey, you don't want to watch me do that slowly. 637. Was that what I said? What I said? 635. Okay. I was like, no, it should end at 5. I thought I was multiplying by 5 at some point. Hooray! Okay, so that's how you do those. Last one, sum of geometric series in context. So here's some word problems for you for geometric series. Okay, Caden was offered a job. We did an example like this already. Okay, so let's look at a new one. A large company put out an advertisement in a magazine for a job opening. Okay, the first day the magazine. Okay, first of all, when we're reading a problem like this, let's go see who's checking in. All right, let's carry on, everyone. I actually totally forget where we were. Okay, yes. So when we're looking at a problem like this, we want to know what is our A, what is our R, and what is our N. Those are the numbers that we're hunting for, right? Because those are the numbers that we feed into our formulas. So, I'm very popular by email. So let's find them. A equals the first term, R equals the ratio, and N equals the number of terms. All right, so let's read it. Large company advertisement magazine for a job opening. The first day the magazine was published, the company got 128 responses. So there's our A. That's going to be the first day, the first number of responses, 128. Okay, but the responses were declining by 25% each day. Geometric. All right, so the ratio is going to be 1 minus 25, if you recall from exponentials, or 75%, or 0.75 is our ratio. How did I find that? Well, I thought about it, and I thought, if this goes down by a quarter, then there's going to be 3 quarters left. It's going to be 75 cents left on the dollar. All right, so that's how I got that very quickly. But you would do that if you had an ugly number, you would say 1 minus this as a decimal. That's your R. That goes there. And then N. Assuming the pattern continued, how many total responses would the company get over the course of the first 11 days after the magazine was published to the nearest whole number? Because, of course, they can't get half a response. So we want this to be approximate. It's going to be an approximation after this stops giving us integers back. That's the power of 2. So it's going to give integers for a rather long time. Okay. And this will actually approach an integer as well. It's pretty cool. So n is 11 because we were asked for the first 11 days. So let's just use our formula. S at 11 is equal to, I'm not writing everything out again for you. A is 128 multiplied by 1 minus r to the 11 over 1 minus r. Okay. S at 11 is equal to 128, which is 128. What? Yeah, 128. The 2 goes in between the 8 and the 1, Mr. Jennings. Multiplied by 1 minus. So let's actually do that on the calculator. Hold on one moment. Let's see who. All right, so carrying on. So we've got our A, our R, and our N, and we are putting those into our formula here. And now we are going to do this on a calculator because, well, I'm not a math savant or something. So I'm going to do it this way. Oh, look, Mr. Jennings is learning. Okay, clear. So 1 minus bracket 0.75 end bracket raised to the power 11 equals, there we go. Yeah, it's a number very close to 1 is what I was expecting because we're raising something that's less than 1 to a large power. So this is going to be nearly 0. Okay, but it's still going to be important to our answers here. Okay, so I'm going to multiply that by doing the top here. I'm going to just write this out. So this is in here in the bracket 0.9578 or so. That's to 4 decimal places. Divided by 1 minus 0.75, that's 0.25. Okay, so now let's do that on the calculator. Multiply by 128 equals, that's what's on the top, divide by 0.25, or multiply by 4 would be the same thing, 490.3. So round to the nearest integer, 490. So they get 490 responses to this ad. Yay! All right, so that's how you do this stuff, everyone. Okay, so any questions, hit me up in the chat or by email. Bye for now.